In the second part of this acceleration lecture, we're going to look at a couple of key different points. The first is, as we mentioned in the previous section, an acceleration of 4 meters per second squared means an object's velocity will be increasing by 4 meters per second every second. So it's 4 meters per second per second. However, sometimes you might see a negative acceleration. So you may see an acceleration of minus 4 meters per second squared. That could mean that the object speed is actually decreasing by 4 meters per second every second. So if they started off at 8 meters per second, a second later they'd be at 4 meters per second, and another second later they'd be at rest, 0 meters per second. And that's sometimes referred to as deceleration. It could also indicate something related to the direction of acceleration, which we'll get onto in another lecture. One thing we need to look at is an alternative way to calculate acceleration that relates acceleration and distance. Now, this isn't a formula you need to remember for your exams, but it is one you need to be able to apply. So this formula links similar things to before: the final velocity of the object, the initial velocity, the acceleration, but this time it also links the distance. So I'll show you this in terms of symbols so that you know and recognize it. Remember, we said final velocity was a v, so it's v squared, minus the initial velocity, which was a u, so it'd be u squared, and that equals 2 times acceleration, which was a, times x, which was our distance. You'll notice that this one is quite useful because nowhere does it feature time. So if we don't know the time, but we know the distance, then we can use this formula instead. So we're going to try this with our example, as I mentioned. So we're going to look at a car that is traveling at 15 meters per second, and it accelerates at 1.5 meters per second squared over a distance of 50 meters, and we want its final velocity. So as always, we're going to write down our variables. We don't know v. We know our initial velocity is 15 meters per second. We know our acceleration is 1.5 meters per second squared. And we know our distance is 50 meters. Our formula, we want to work out v. So we're going to need to get rid of this minus u squared. Whenever you move a minus over an equal sign, it becomes a plus. So our formula ends up being v squared equals 2ax, that just means a times x, plus u squared. So we're going to put our numbers in now. So v squared equals 2 times 1.5 times 50 plus 15 squared. Don't forget, we've got to square the initial velocity. So we end up with v squared equals 150 plus 225. V squared equals 375. But don't forget, that is v squared. So if we want to find out v on its own, we need to do the opposite of a square, which is a square root. So v equals the square root of 375, which gives us a final velocity of 19.4 meters per second. Don't forget your units at the end.